So real quick, surgery's next Thursday. I'll be gone Thursday and Friday for those of you guys that weren't here. We have school off on Monday. I should be back Tuesday. According to the calendar, I haven't changed the calendar based on surgery date. That just kind of happened yesterday. Right now, where do I have you guys next week? Oh!
Really?
I have you guys taking a test anyway. So, hold on. Right here. So my surgery's here, and then I'll be gone here, and then I'll get another extra day of rest there, and then I'll be back. So hold on. We're going to change this a little bit. I'll change it this weekend to reflect. I think I'm going to move both parts of the test to Thursday and Friday. Wednesday we'll have all-day test review. Yeah, we'll do that. Okay, hold on. I'm changing it right now. Wednesday we'll have all-day test review. Let's cut that. Which will actually be good. And you guys can ask me questions, etc., etc., etc. We'll finish our last section on there. And then this day, let's move him over here. Is that better? No, where'd he go? Uh-oh. I lost him. Oh, there he is. Ta-da! Okay, so remember that the Chapter 5 test is going to have two parts. The problems with the formula sheets are going to be on Friday. Formulas, and you get, or the problems with, you guys, I'll give you the formula sheet for the problems to use. We'll figure it out. Maybe you can use your graphing calculator. That's going to be on Friday. On Thursday is going to be your formula portion. Formulas from all of Chapter 5. You're going to see some new ones today. However, I doubt that'll take the entirety of class because you're literally filling in. So then the rest of class, you guys can keep working on the test review some more and keep helping each other. Sound good? To get ready for the problems? Okay. So we're going to have a test review together with me on Wednesday. And then you're going to have the formula part for the first half of class. And then I'm guessing like half of class is all it'll take. Maybe like 2/3. And you'll have like 1/3 just to work together. So hopefully you can ask me as much as you can on this day because I won't be here in senior batch. I won't know how to answer. And then... Oh, was he? Yeah. He's awesome. And then, in this one for Friday, you'll just have test part 2, and I'll have formula pages to print out, and then we'll start section 6-1 on Monday, and then I have to move all that other stuff, but that's okay. Is that cool? That'll work out just fine. All right, number 4, extraneous. We'll see what questions you have. I know yesterday might have been a little hard with me not here, and with the video going loud and soft. But just quick heads. Oh no, you're not going to listen to the video next week. Never mind, we're good. Number 4, extraneous. Remember an answer that seems to be right, but you check it, it doesn't work. Oh, that's extraneous. Number 14, solve, solve, solve. Move the signs together. Move the 1 to the other side. Divide by 2. That happens where in the 3rd and 4th quadrants they said all, so plus 2 pi n. Did they say in radians? Did it have to be in radians? Okay. If you did it in degrees, it would just be 210 plus 360n and 330 plus 360n, just in case you did it that way. So 7 pi over 6, 3rd quadrant, 30 degrees, and then 11 pi over 6, 4th quadrant, 30 degrees.
I'm having an issue with this tangent of like 3x.
Okay, yeah. It's weird, right? But hold on, where do you still start? You don't start with a 3x, you start with a square. Plus or minus.
Yeah,
so all quadrants, right?
Yeah, it's not exactly.
Yeah, I stopped there.
Okay. Well, we can't get to the 3x. Think about it. Tangent of. We can't get to the 3x until we deal with the tangent. So the first step is ignore the 3x. Like he just comes down. Think tangent inverse. Think when is tangent plus or minus root 3. And then you're going to deal with this by dividing. So, if you're thinking plus or minus square root of 3, well, hold on. Tangent is root 3 when sine over cosine is root 3 over 2 over 1/2. When is sine root 3 over 2 and cosine 1/2? 60 degrees. Now, if you do the cheater chart, couldn't you look under 60 and you know that tangent is root 3? Yeah. So this is when the cheater chart is nice because you guys kind of memorize those tangent values. It happens at 60 degrees or pi over 3. Now, the weird thing is they only have one formula written. Some of you might have written two. Can I do a pen in Word? I should be able to. Hold on. Okay.
Why is it plus pi n over 3 instead of just pi n?
Let me show you. So, if you're thinking unit circle, 60 degrees, right? Tangent is positive root 3. Where else is it positive root 3? All students take this pi over 3, right? So we have first quadrant pi over 3, we have third quadrant pi over 3. Where is it negative? Second quadrant and fourth quadrant. True?
Yeah.
Okay. However, even though there are four places, they were able to just write two formulas. I mean, they changed the two formulas, but they were able to write two formulas because they said, hey, if I take quadrant 1, pi over 3, and if instead of adding 2 pi n, I only added pi n, who else would you get? You get quadrant 3. So what they did is they were too lazy to write four formulas. Instead of writing pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n, which would have been right, they said if we just write pi n, sweet, we get 2 in 1. Because then another pi will get you back to 1, another pi will get you back to 3, another 1 will get you. So they just shortcutted. They were being lazy. They did a shortcut. Now, they also used 2 pi over 3 because of the second quadrant. But if they changed 2 pi n to pi, who else would they get? The fourth quadrant. So once again, they were too lazy. I mean, they're mathematicians. They like shortcuts, right? They didn't want to have to write formulas for each. They said they're just pi apart. So adding 1 pi gets you there, another pi gets you there. It's a half circle. So they just shortcutted the process again. Now, this is when tangent is positive root 3 over 2, positive root 3. This is when tangent is negative root 3, but you still have to solve for x. So how do you get x alone? Divide by 3. But when there's an addition, you have to divide both sides by 3. Or multiply, if it helps, multiply everything by 1/3. Does that make sense? So 1/3 here, just x. 1/3 here, pi over 9. 1/3 here, pi n over 3. Does that make sense? Same thing here, multiply by 1/3. Distribute to everything, one side and the other. The addition says to both pieces. Is that cool? Tricky. Tricky. But just think about it one more time. Tangent of, we don't deal with the 3x, we deal with the tangent. And say, tangent, when are you? Get our answers. Then divide by 3 to get to the x. Done. Alright, let's keep going. Nice thing, guys, that is on the video if you need to see it longer, yeah? Okay. Oh, that's not working well. Hold on. Okay. Number 28. You couldn't solve him until you got sine squared to be 1 minus cosine squared. Did you guys plug in for that one? Sine squared, 1 minus cosine squared? Right? Wait, why are there 2's? Oh, yeah. 1 minus cosine squared, the 2 comes in. Got it. Then what did they do? Move it all to one side. Why? You got to do some factoring, right? Exactly. Pull out that common cosine. As soon as you have factors equal to 0, what do? Take each one equal to 0, right?
Every time you factor out something, okay, so I didn't do like that, but I divided by cosine.
Ooh, the problem is if you divide by cosine, it goes away. So whatever answers he would have had, you just would have been missing. You know what I mean? So dividing by cosine isn't bad, except you're going to be half wrong because you're missing, you kind of eliminated the answers that should have been there. That's why with factoring, you always have to think, set each factor equal to 0, because as soon as you divide, you just get rid of half the answers.
The problem is it didn't factor.
Oh, you added. Divided? Oh, that's what you did. Yeah, so up here the 2's would have canceled, right? Is that what you did? The 2's went away.
Yeah, I ended up,
Then you said, let's divide by cosine.
I turned the equation into a negative cosine equals 2 minus 2 sine squared of x. Because then I factor out the 2 and I have 1 minus sine squared of x, that's cosine squared of x.
Oh, okay. Yeah.
And then I divided both sides by cosine of x. Because I had a cosine squared of x on one side.
Yeah. But see, when you divide, you got rid of him, and so that's why you're missing, you should be missing, I think, these answers, right?
Yeah, that's what I mean.
Yeah. So careful, division is valid for getting down to like if there's only one answer, but in any of these where there's multiple possibilities, you don't want to divide because you're taking away something. Does that make sense? And then at this point, guys, unit circle, right? You have to think of when is cosine 0. How many of you guys are having it, and this is totally fine, how many of you guys are either writing the chart or you're having out a unit circle that you can reference? Good. Good. That's not a bad thing. Just make sure for the test you get to the point where you can write something to help you out during the test for it. And if any of you guys are stuck, get out a unit circle. You don't have to have it memorized perfectly right now, right? Work on the problems and just realize what you're using that you need to have figured out by the test in the sense of, okay, I need to write my chart at the very beginning of the test, or I need to write the first quadrant or something like that. Okay, next one. Uh-oh, that didn't work. Number 36. Guys, this looks like beginning of chapter 5 stuff, right? Like plug in something, put it together, get a common denominatory thing, use your properties. Like we're just kind of using 5.1, 5.2 skills. So if this is kind of hard, maybe you've just kind of forgotten what we did in 5.1, 5.2, which is totally valid. This weekend, take some time. We're not going to finish this section today. Oh, we are supposed to finish the section today. I forgot about that. It's a short section. But take some time and just go peek at 5.1, 5.2. Go peek at 5.1, 5.2 and just kind of review a little bit. Because we did a lot of problems like this. So plugging in the quotient property, sine squared over cosine is going to be added to cosine, but cosine doesn't have a denominator yet. So we need to make them match. To make them match, common denominator of cosine x, right, on top. All over cosine x. That's where we get cosine squared over cosine plus sine squared over cosine. Put it all together. Pythagorean, secant. Oh, they didn't like secant. They multiplied and then they said, forget it, let's stay with cosine. And they must have given you 0 to 2 pi, is that right? So 0 to 2 pi, you were just looking here, and the question is, where does cosine equal 1/2? Adjacent is 1/2 at 60, or pi over 3. And it's also positive 1/2. All students take calculus positive 1/2 in the 4th quadrant, or 5 pi over 3. So there's 1, there's 2, and those are the only legal ones. How did reading directions go? Knowing how many answers to get? Okay, good. Doesn't mean perfect, but as long as we're getting the idea. Number 40. That one's a little more straightforward in the sense of, remember, deal with who first, the 2x or the sine? Deal with the sine first. Remember, this one's stuck. Deal with the sine. When is sine negative root 3 over 2? Sine is negative, all students take. Sine is negative here and here. At 4 pi over 3 and 5 pi over 3. You could have gone negative, I suppose, but since they already went all the way around, they just kept on going. So 4 pi over 3, 5 pi over 3, adding the 2 pi, then divide everything by 2. Or if you don't like that division, it's okay, right? Multiply everything by 1/2 instead. Just like we did in the problem before. Distribute, and you got it. Yeah. So then our final answers. Number 60. Oh, you were allowed to go in your calculators. I showed you that example in the notes yesterday, right? We did a calculator one? Okay, cool. So all you had to do is graph this entire thing. What function did you guys use to solve for this? Zeros, right? Hold on. Did you guys get this far in the video? You finished it?
Oh, was that the last example? It was really
The last one went really fast. Can I peek at it? Yeah, this one. Did you guys see this part? So I took this equation, not the 0, but I took everything else. I plugged it in the y equals. There we go. I plugged it in the y equals. You have to do all of sine cubed. It's like a big old parenthesis, cubed or squared or whatever you need. Then you graph it, zoom trig. I made the window whatever they were asking for. This one was 0 to 2 pi in the example. This one looks to be 0 to 2 pi as well. So then we restrict the window. So I cut down the window to make it 0 to 2 pi instead. Then I find each of the equals 0. Find each of the zeros in your calculator. You guys remember where to find that, right? Go to your calc menu. Oh yeah, people started getting loud, sorry. Find the 0. Remember, go a little bit before the 0, a little bit after the 0. Calculator will approximate it. There's a decimal. I found 1. You guys just use the 0 feature for the rest. That's what you were using for this problem, and that's how you would find 1, 2, 3, 4 answers, 4 zeros, a 1 and a 2 and a 3 and a 4. But it's going to be way different if you guys were in degrees, right? Looking at these numbers, that's definitely the radians they're supposed to be. Number 86, you were also able to use your calculator to see how many answers. There were 3 intersection points if you graph these two. So there are 3 solutions because the graph in your calculator would show 3 intersection points. You might have had a restricted domain on that one, like a cut your window down. And then number 94, oh, those are little baby pies. I don't know what's going on there. Was 94 the Ferris wheel problem? Let's just pause on him for now, is that okay? He's not a big deal for the test or anything like that, so we'll just pause on him. He's a great problem as far as like application, like a physics sort of thing, but we'll just stop. Okay. Hard things in homework. Remembering 5-1, 5-2 stuff. That could have been hard. The weird 3x inside sine or 2x inside tangent or whatever you had. That was a little weird, but we looked at it. And then remembering your unit circle. All of those might have been hard. We're not going to do this extra example, but I am going to go ahead and go peek at them. Let me minimize this real quick. Where is it? Oh, there it is. You might have had an example like this one. I think it lets you use your calculator, so it wasn't a big deal. The question, why are they telling us to use the quadratic formula? Why not just factor? 1 factors of 1 that make 3, are there any? No. So how would we use the quadratic formula if we had to solve this algebraically without a graphing calculator? Well, quadratic formula, unless you want to complete the square, which you could, says x equals negative b plus or minus, anybody? Square root b squared minus. All right, now we all join in. Okay, but hold on. Isn't that when you have x squared? Jesse, move that one. Come on. Your seat's that one, huh? Yeah, I think I said that for one day was okay, and we'll see how it goes, but there's been a bit of challenge. So once you go ahead and so x equals negative b plus or minus square root b squared minus 4ac all over 2a. But that's when we have ax squared plus bx plus c. Question, who's squared now? Not x, tangent. So we're not going to set x equal. What are we going to set equal? Tangent. Okay, that's sad but true. This is going to be like lecture for probably the next 5 weeks-ish. Now, if I get wheels, I'll probably be able to go up to the board a little bit more. But you have to be able to learn with a teacher who's not jumping around and flashing her hands and trying to get your attention 24/7, okay? But just a heads up, college teachers aren't very much jumping around, waving their hands, trying to get your attention, trying to force you to learn. They're like, whatever, if you fail, no skin off my nose, I still get paid. They're still nice, and they still care, a lot of them, but come on, you can do this. Some of them. Anyway, how would we solve? We would get this little number, we would ask ourselves the question, when is tangent this thingamabobbers, and then we'd go. Is that cool? I just want to remind you of the quadratic formula. All right, here we go, section 5.4. Let's ignore all of that. We've talked about already, just double checking, we've talked about already the whole deal how inverse trig can also be called arc trig, right? Have we talked about that? Like arc sine is sine inverse, etc. Okay. This is just a quick reminder that it can be shown either way. But otherwise, let's go ahead and just get you in the next page of notes. And as you see this, you will see why I've been talking about formulas. Because guess what? Now we have new ones. There are ways of remembering. There are ways of memorizing to shortcut the process, but there are ways of remembering. There are ways of shortcutting the process, but long story short, some of you guys, depending on your memorization skills, which you should know from other classes, etc., use what works for you to get these down. Fill in the blank, part 1 of the test next Thursday. But the nice thing is, even though we have new formulas, nothing else is new. Besides the fact that we have new formulas, nothing else is new. What do I mean by that? We're going to do some T-proofing. We're going to do some following directions and playing with whatever they tell us to do. Sorry, it's good again. We're going to do some solving some equations. Just now with a few new formulas tacked on to the old formulas from section 5.1. So, advice. And just to help you with that, advice. Hi. Advice. How many of you guys are flipping back to section 5.1 looking at those formulas? Start making a formula sheet. Put those formulas on. Now what are you going to do with this section? Add these formulas on. Why? On the test, you get a formula sheet. Don't go wasting time flipping back and forth. Make yourself a formula sheet. You can study from it, but you can also use it for all your homework problems. You don't have to kill your brain to remember them. Because if you try to remember them to do a problem and you do it wrong, oh man, you do all that work and then it's wrong, right? Anyway. Those are my 2 cents just in case. If they don't, they don't. I didn't tell you guys happy Friday, did I? Happy Friday. Oh, I did. Who's gonna get some rest this weekend? Try to recuperate.
Still gonna get into the time sheet. I think better like 8. Yeah.
You getting up early though?
Yeah.
Are you getting stuff done early, or is it just like annoying you can't sleep?
It's just like it's a 6-hour difference from yourself. So
it's
8
all
o'clock would be 2 in the morning there. Something like that.
That's why.
Then waking up with so much energy.
Oh, because it's so hard to switch from. Because you're. Okay, I was gonna say 12 or something, 16. Because you're totally flipped. I have a friend who moved. She and her husband and kids all moved to go work in China in Yantai. And so I can talk to her really early in the morning because it's late at night for her, or I can talk to her really late at night. Otherwise,
Plus, I'm waking up with like so much energy because I slept so much. Yeah.
that's not a bad thing. It's a nice
Yeah,
thing.
that's a good thing.
But it's hard for homework, huh?
Yeah.
Oh, because you have soccer. Oh, you guys are traveling today.
No, thankfully we're staying.
As you guys are looking at these formulas, do you see any patterns?
Yeah.
Right? So, okay, there are 6 formulas. But question, aren't there really just 3? Really? With different 2 variations of each? There are really 3, just 2 variations of each, right?
Yeah.
But the dilemma is, okay, what's going on with sine? And cosine. Here's how I remember it. Take it as you want. cosine, what does the co mean? Okay, in math complementary, but in English, what's co mean? With or together. The cosines are together, and the sines are together. Do you know what I'm saying? Or what I'm saying? For the cosine? The cosines are together, the sines are together, right? And so if the cosines are for cosine, the sum and difference formulas, if we figure out cosine, sine's the other one. What does that mean?
They're not together.
Sine, cosine, cosine, sine. They're not together, right? They're separated. So that's one thing. With cosine, co with or together. Sine, well, they're not. How about the sines, though? With the sine sum and difference, the sines stay the same. And with the cosine sines, the sines change. Oh, okay. So if it's an addition, then for the sine, it's an addition. For the difference, okay, it's going to be the difference. For cosine, addition is going to be subtraction. The subtraction is going to be the addition. Now, tangent, okay, it's rough. Like, you kind of have to memorize. You technically could do for tangent of u plus b, could do sine over cosine and try to simplify. Don't do that. I used to have to group them, or I used to group them in another book. Okay, we're just going to use it. Tangent u plus tangent b plus or minus, if you look at them on top. And on the bottom, 1 minus tan u tan b or 1 plus tan u tan b. How do you remember the signs though? You have to kind of memorize what it looks like. Tangent is sine over cosine. So the sine, same, cosine, change. Oh, you have to memorize what goes where, but the signs work. And then for the difference, sine stay the same on top, cosine changes on bottom. Anyway, there are ways of remembering, there are little devices that you can use to try to help yourself out. There are little tricks, some of you just need to out not memorize, you do you, okay? But basically, hey, we have new formulas, they're important, we can memorize them, we can use them to do all the stuff that we use the other formulas for. Like what? Like evaluate. Like evaluate. Yeah, like evaluate. If we were to simplify this, if we were to say, okay, PEMDAS says start in parentheses, right? We could say, this is the same thing as sine of, what is this angle? Well, we can't really tell what the angle is unless we get common denominators.
4, 5, or 6.
Yeah, we could change this one to pi over 6, right? Multiplying by 2 over 2. So we could say sine of 5 pi over 6. Now, is that a valid way of solving? Yes. That's a valid way of solving. But I'm just giving you a heads up. Sum and difference formulas allow us to solve some things that aren't going to make a nice unit circle angle. Sometimes you'll have things like maybe 7 pi over 6 and pi over 2. That would work too. What's one you
About
pi over 4?
5 and 19.
Pi over 4. What if you have 7 pi over 6 and pi over 4? You have to go to 24ths, no 12ths. And 12ths aren't in unit circle. But with sum and difference formula, we can take them separately and not have to put them together, and we can see if it ends up equaling the same thing. Now, maybe some of you are still rusty on the unit circle, but those of you that do know the unit circle, what is sine 5 pi over 6, 30-degree reference angle, second quadrant? 1.
1 over 2.
Alright, let's check and make sure the formula works. For the formula, we need a u and we need a v, right? U is going to be 7 pi over 6, v is going to be pi over 3. So then with u and v, we need to figure out how do we plug in sine, not with or together. So, sine of u with the cosine of v. Sine stays the same, minus. Cosine of the u, sine of the v. That's different. And how do we actually solve it? I know, you're like, this is annoying. You know what the answer is. It's 1/2. Remember, I just said the sum and difference formula, there's lots of uses to it, and it's not just solving this very first example I've given to you. So question, how would we keep going to solve? Unit circle, right? What is sine of 7 pi over 6?
That would be negative 1/2.
Yep, because it's in the third quadrant, right? So we have negative 1/2 for that one. Times, that's the operation, right? What's cosine of pi over 3? That's 60 degrees, first quadrant. Cosine is? Double check me, but I think it's 1/2, yeah? Minus cosine of 7 pi over 6. I believe it's negative root 3 over 2. Sine of pi over 3. Positive root 3 over 2. Right? Multiply. Negative 1/4 plus square root squared, 3/4. 3/4 minus 1/4, 2/4, which is 1/2. Does it work? Yes, and it always will. The sum and difference formula is one that is always true no matter what angles are in the U or in the V, but what I need you to see is that what you see over here on the left is not the same as what you see over here on the right. Why is that so important? If you think these are the same, well, first of all, why might someone think these are the same? Yeah, they're like, oh, it's sine times, sin times, sin times. We don't ever want to multiply sin, right? Think about it. Bad idea. Right? So, don't multiply sin. Or, remember, there is a special formula for how to do this problem, breaking it apart. This is not the same. And if I can take just a quick second to prove that to you, if we were to solve this, sine of 7 pi over 6, we already mentioned was negative 1/2. Sine of pi over 3 is minus positive root 3 over 2. Negative 1 minus root 3 all over 2. Is this the same thing as 1/2?
I don't know, put it in calculator.
No! It's not the same. It's not even close.
So
No,
how do you
no.
solve that?
No. This is how you solve this, but it's a different answer than the left one because you cannot multiply sin. You have to use the sum and difference formula.
Okay.
Yeah? So
That's
the only...
a good way to think it. You cannot multiply.
Yeah,
sin.
right? And then just think or cos or tan or sec or cot. There you go. All right. Now what? Okay, they want us to solve for sine, cosine, tangent of who? 11 pi over 12. But why can't we just use unit circle? Why on earth do we need this section? Yeah, why not just go to the unit circle? Is there an over 12 in the unit circle?
No.
No, and we don't want to memorize any more of the unit circle, right? Yeah. So, since we can't do this by hand, oh, it must be a calculator problem. There's no other way to do, wait, look what they showed us. They showed us 11 pi over 12 can come from 3 pi over 4 plus pi over 6 if we got common denominators of 12ths and put it together. Oh, so if I want to find the sine of this, what else can I find the sine of?
Both.
The other side. Why do I like the other side?
Because it has unit circle.
It has unit circle values. But can I multiply sin? Nope. So I have to use what instead? The sum and difference formula. The only legal way to break this down. So, sine, not with or together, right? We have to do sine of one of them. Cosine of the other. What happens with sines, sine? The sum and difference sign for sine? Good, stays the same. Then we're going to go ahead and switch it up. Sine of u, cosine of v. Cosine of u. Sine of v. And even though we could not even begin, I mean, we could maybe have approximated, but we couldn't have known for sure 11 pi over 12. Psh, we can do all these pieces. It'll take a little bit of time, but we got this. Sine of 3 pi over 4. And it's positive because it's in the second quadrant, so we have root 2 over 2. Cosine of pi over 6, 30 degrees first quadrant. Square root of 3 over 2. Plus cosine of 3 pi over 4. Second quadrant, cosine is negative. Times sine of pi over 6. Multiply these out. Oh, this is a gorgeous number, right? Just kidding. Root 6 over 4 minus root 2. Oh, hey, that root 2 is also over 4, right? So let's just combine it and get a common denominator. Let's not do that. There we go. Now, some of you might think we can go further, but if we can't square root 6 or simplifies, or square root 2 or simplify, and they're not the same square roots, we're stuck. Dun, 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 dun. Nasty decimal. Okay? Now, what would we do if there was a cosine? Because they technically, we just did one of them. If we wanted to do cosine, we would have to redo everything, but instead of using the sine sum and difference formula, we'd use the cosine. And if we want the tangent, instead of using either of the others, we would use the tangent one, right? Okay, if we had time and if I was up at the board, we might have gotten further on this example, but we'll just keep going. Ah! Oh my goodness, what does this one tell us to do? Oh hey, wait, they already did all the hard work. Oh, but we have to do every single one of them? I guess so. Or, check and make sure that the simpler side, which would be the other side of the formula, isn't unit circle. Hold on, who is this guy? Isn't this a tangent sum and difference formula? Yeah. Oh, it's green. Which tangent sum and difference? Is it the sum or is it the difference? Difference, good, because on top stays the same. So we could say, wait, this is the exact same thing. We can go backwards with our formulas too, which is going to help us with t-proofs, etc. Because if we look at this big, huge, nasty blah and say, wait, he's just tangent of the one, you can check it, minus, it's the difference formula, the other angle. Wait, this is looking good. Can we do this?
No.
Oh, yeah, we can. 5 pi over 6 minus 1 pi over 6 is 4 pi over 6, and 4 pi over 6 reduces to be, is that a unit circle value? Well, then forget it. Who on earth is silly people that would actually try to solve that? Just kidding. That's a valid technique. But let's choose the easier if we can figure it out, right? 2 pi over 3, we have a 60 degree in the second quadrant. Tangent, my chart people, you can do 60 degrees and make it negative. My other people, root 3 over 2 over negative 1/2. Dun, 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 dun. Doesn't that look easier than that? Yeah. Another application. What? I don't. They give you the numbers to plug into the formula. You don't even have to do the angles or do the unit circle. You just have to plug and chug to who? Co. Stay together. Co of u times co of v. Cosine, sorry, I don't know why I just shortened that. Sines do what? Change. There you go. Sine u, sine v. Now here's the most common mistake. A lot of people see these numbers and say, uh-oh, we have to plug it into the u spot. No, you don't. You plug it into the whole spot. I'll get there in a second. Sorry, sine of v. What does this take the place of? This whole thing. So I can go ahead. The sine's gone. I'm getting rid of the sine. I'm plugging in 5 over 13. Who else do I have? Cosine. So that one goes over here. This one goes over there. So negative 3/5 takes the place of cosine. But wait a minute. Aw, stink. They didn't give us enough information. Oh, is it the imaginary bell beep? No, we still have... Yeah, Yeah, we still have 45 seconds. You guys. How do we find the other side? We say, uh-oh, these are what? If I have a 5 and a 13, guess what? I can know that for you, cosine is supposed to be 12. And then if I know a 3 and a 5, I know sine is supposed to be 4. Plug it in, go.
How can you get multiply cosine and sine b?
Oh, because remember, the cosine sum and difference formulas are different than the sine ones. Wait. So cosine, I have to follow the pattern. That's why we need to add that to our formula sheet and have it ready to go. Sound good? All right, kiddos, do the best you can on homework. We might have to do a couple examples of tricky ones on Monday.
Have a good weekend, Lucy.
Bye, guys. Well, let's pretend that homework's due on Monday because it's supposed to be.
Let's get it.
Thank you. Bye, guys.